our lab this week is over the simple pendulum. So again, if you click on the lab folder here, you'll see experiment for the simple pendulum. And always, first thing, click to download the procedure. This is important experiment because we learn how to do controlled experiment. This is actually a very good example of how scientists control their experiment. We are trying to find out what are the parameters that impact the period of the pendulum. And to understand the period, let me download the simulation here so that you can see this is the simulation. And you can just click control or hold the control button and then click on it to download the simulation. And now you'll click play and you'll select the lab here. Okay, and this will give you the simulation. You can see here there are 3 parameters that we can vary here for this experiment. We can, this is the pendulum here. Pendulum is simply a rope connected to a mass. And if you shift the pendulum here and release it, it will start swinging. Okay. Now, if there is no air resistance or if the air resistance is very small, this swinging will continue at equal rate. That's why the pendulum is used to build clocks. Okay, you remember the old clocks, the grandfather clocks? It's a pendulum based because actually it goes through equal cycles, back and forth equal cycles. We call it the period. The period is the time taken to complete one cycle. This is actually, I can show you here a cycle. This is a period timer. You can see here, yeah, this is a cycle going back and forth, one cycle. So the question is, what are the parameters that change the period of the pendulum? We have 3 parameters that we can test, which is the length. We can increase the length and we can decrease the length, as you can see here. Increase it and decrease it. Also the mass, we can increase the mass, make it big or make it small. You can see we can go from 0.1 kilogram to 1.5 kilogram. In the case of the length, we can go from 0.1 meter to 1 meter. And the other thing here, we are not going to touch gravity. Gravity is another factor because we'll assume we are always on the surface of the earth. We are not going to vary gravity. We'll vary the angle. Okay, so here if I hold the pendulum, I can go 2 degrees, 3 degrees, 6 degrees, as you see here. I can vary the angle. So those are the 3 variables we are going to test whether they affect the period of the pendulum or not. But in order to do that, we cannot test them at the same time. So each time we test a variable, we have to do what? We have to keep the other 2 variables constant. Okay, we have to set the other 2 variables constant. So if we are testing the length against the period, we have to keep the mass the same and we have to keep the angle the same. Okay, and we have to change the length each time and see if there is impact on the period of the pendulum. Okay, remember here the period will be the dependent variable. Okay, the period will be the dependent variable, while length, mass, and angle will be the independent variable. Remember, the independent variable is the variable that we manipulate, we change, while the dependent variable will always depend on the independent variable. Okay, so that's why here, if you look at the procedure here, going back to the experiment, if you look at the procedure, we have 3 tables. Let me scroll down here. We have 3 tables. The first table is period versus length. This one here, where you vary the length and then you have to record the value of the period. And during that time, you have to set the mass constant and the angle constant. So the mass is always 1 kilogram, the angle is always 5 degrees, and you change the length from 0.2 meter to 0.4 to 0.6 and so on. And each time you record the value of the period. If there is no change, okay, if there is no change in the period, then you can tell that the length is not impacting the period, meaning the period is independent upon the length. And now, important point, guys, here, when we talk about change, we are talking about something more than 0.05 seconds, because there is always human error within 0.05 seconds. So, for example, if you got something here like 1.05, then on the next one you got 1.09. 1.05 and 1.09 have 0.04 seconds difference between them. And 0.04 seconds is within the human margin of error. So it does not indicate change. 1.05 is basically equal to 1.09 within the margin of error. So don't say that if there is change within 0.05 second, don't assume that this is a change. This is just a human error. So the change should be significant, like going from 1.05 to 1.55, for example, or 1.05 to 1.72, and so on. So you should see significant change, more than 0.05 seconds, okay? And you'll do the same thing with the other variables. For the mass, when you test the mass against the period, you have to keep the length and the angle constant. And finally, when you test the angle versus the period, you have to keep the length and the mass constant. So we always control the other variables by setting them constant. Then also at the end, there is some calculation that you need to do. Okay, and I gave you example here. The first calculation, I gave it to you actually. I showed you how to calculate it. So make sure you follow this example that I gave you. This is the only maybe math part in this problem, okay, doing this calculation in this experiment. So to do this calculation, you have to divide 0.2 by 9.8 first. And then after you get the answer, you take the square root. Then you multiply it by 2 times pi, okay? And pi is 3.14. Now the questions are all multiple choice. So first, answer those questions here on maybe sheet of paper. It tells you what's the corresponding question in the lab assessment. All the questions, as I mentioned, in the lab assessment are multiple choice. So this will be question number 13, this is 14, this is 15. And remember, you have 2 attempts. If you got one or several errors, you can take it again. But make sure you know your mistakes. And let me remind you guys, always the second attempt, those questions will not be in the same order, or those choices will not be in the same order.